So we're in a situation where we have a global pandemic. The only thing we can do is rely on everybody. If everybody needs to battle the virus by means of social distancing, hand washing, wearing a mask, one important requirement for people to be motivated is for them to understand the scale of the threat.
We've been doing research on the perception of exponential growth for a few years now, and as people in fact have known for centuries, we are very bad at estimating this. That is the problem of exponential growth bias, when people underestimate just how fast the disease spreads.
So in order to study this question, what we did was an experiment. We take the same situation and communicate it in a different way.
Participants were randomly assigned to one of 4 treatment groups and tested different ways of communicating exponential growth. So we have the same scenario, a fictional country in which there are 974 cases of this infectious disease. What we ask them is, what if we slow this down, if we lower this exponential growth rate?
Bring down the growth rate of 26% to 9%. And then we wanted to know, what do you think is the benefit of that? The typical participant said 8,600 people, that's the median. Now the true value is avoiding 1 million cases.
Compare that to where we asked for the time until 1 million cases will be reached and use doubling times. There the correct answer would be 50 days. So the country would gain 50 days by adopting mitigation measures. And in fact here there was no systematic underestimation.
So which is the best way to communicate, at least in our study? It's to do 2 things. Number 1, use doubling times. And number 2, ask for time gained.
How much time have we got left until intensive care facilities are full, for example? By communicating in these terms, people might be able to understand both the spread of the disease better, but also the benefit of mitigation measures and the impact that these mitigation measures and their own actions can have.